Good morning, ladies and gentlemen. A warm welcome to another Zoom session here from the U3A in Hermanus. This is the second lecture in a series on the geology of the Overberg region. And in particular today, we'll be learning more about the famous cliff path along the waterfront in Hermanus. To take us through this, I'm glad to welcome John Blaine. John is a graduate from the University of Cape Town with an MSc in geology in 1977. He worked on base metal mineral exploration projects in metamorphic and igneous rocks and on diamonds for 43 years on behalf of Canadian and Australian companies in Southwest Africa or Namibia, in South Africa, in Botswana, Rhodesia and now Zimbabwe, in Zambia, Mozambique, Canada, and in Swaziland, which is now Eswatini. John said he did not know much about the Cape Fold Belt and the Cape Supergroup rocks until he moved to Hermanus with his wife Kathy in August 2017. John, thank you very much for your preparation, and we're certainly looking forward to your presentation this morning.
When we were at UCT, the mountains were all around us, but we seemed to focus on the beach. There were certain geologists that did a lot of mountain climbing, but I wasn't one of them. And I eventually went over the mountains and worked mainly well north of the Karoo for most of my career. So coming back down here to Hermanus, it's really been quite an eye-opener to me to really observe and be more involved in this incredible geology we have around us. So without further ado, I live just up the road from the cliff path, so I focused very much on what's right on my doorstep. And this doesn't in any respect pretend to be a scientific endeavor at all. I've gleaned and gathered from various sources and resources, of which there are a lot, and really just tried to apply my mind to what I see. And we've turned this into one of a number of these Geowalks which we're planning around the Overberg. And what I've intended to do here, laid out as a self-guided tour. It's a good spot to start a self-guided tour at Gearing's Point, because you get this beautiful view over Walker Bay. You can see all the way from Danger Point on a clear day, which would be straight in front of you, going up Pachrace Bay. You've got the Klein Rivier beach, right through the grotto, and then the mountains of the Olifantsberg containing the Monsterkop, Mosselberg, Manskeinkop. On the west side, you see the gently sloping, seaward sloping rock faces that come up to the 20-30 meter wave cut terrace on which Hermanus is situated. Now, this terrace is quite an obvious feature of the Hermanus area and was likely cut during the Pliocene or Pleistocene period between 2 and 5 million years ago. But it's not particularly well dated, it seems, and that's obviously a point that work has to carry on. In other places, there's quite a prominent, what I've called a 3 to 5 meter terrace that seems to have formed during the last interglacial period when sea levels rose and the glaciers melted, and that was approximately 10,000 years ago. Now, I've labeled these stop 1 through to stop 15, I think, but the nice thing about this part of the cliff path is that there's a number of benches, and the municipality has been kind enough to put numbers on them. So it makes it easy to locate yourself. I'm using those as reference points. I'm just quickly going to go through some of the background so that if you're doing the self-guided talk, you will have all this information will come up on your phone. So you would come to the next thing, which will show you a map of the Walker Bay and surroundings, where there's Hermanus, and there's the Klein Rivier embayment. This is Walker Bay down here, Frans Bay over here, and the Kelders. In the background, the blues are the Cape Supergroup of the sandstones, called sandstones of the Valencia Formation, and the pink colors are the basement granite that we heard about last week, the Cape granite, which appears very poorly exposed in a number of these up-faulted wedges. And when I say very poorly exposed, they're poorly exposed, very weathered, but they're very important, certainly in the Human and Arda Valley around here, for the grapes, the wine industry, and also for berries on the west side of the valley up against Babylon Story. And further inland, you then have the Bockerveld group that comes in further up the valley, which is also important for wines. So along the cliff path that I'm looking at, we start here at Gering's Point. The meeting place will be here at Hermanus Pietersfontein. And from there, we'll be able to look back towards the Windsor Hotel and start off the discussion. But I've annotated this map to show basically the features where we will stop, the highlighted or the emboldened bench numbers. The names of the places we'll stop at, like Wasbakkies and Tamati Bank, and then later on there's the Blowhole at New Harbour. So that's just a reference map, which maybe for the future we might make a little bit more graphical, but for that, at this stage, this serves the purpose to show where we're going. So on this walk, the obvious things that stick out are towards the east. Above Voorklip, you'll see these spectacular wavy features in the mountainside of the Monse Kop, and some of the features evident in the cliffs around Gering's Point, and we'll see that below the Windsor Hotel at the Pieren. And these are all indicate similarities to the spectacular folding seen in Meyringspoort, near Oudtshoorn, and in the Trudeau Pass, near Swellendam, and of course Cogmanskloof near Montague. These really spectacular examples of disharmonic cascade fold, which many have ascribed to the process of gravity causing this folding. This information will all be in the handout, but basically these spectacular features are part of the deposition of the Cape Supergroup in the Agulhas Sea, and the deformation that occurred sometime later as a result of even larger scale deformation caused by plate tectonic forces from the south to form the Cape Fold Belt, and leading to the formation of the ancient continent of Pangaea, of which Gondwana was part. This deformation occurred at depths of up to 10 kilometers below sea level, similar to that involved in the mountain building of the Alps and the Himalayas. And starting with the rocks along this walk, you'll see features that tell you about the origin and the history of these rocks and how they make up the landscape around us. Most prominently, we will note a sequence of cross-bearded sandstones which formed on a broad sandy seashore, buried of course by later units within the same sequence, and then ultimately the Bockerveld and Witteberg groups above that. These are later affected by structures, folds, thrusts, and quartz veins that disrupt the homogeneity of the sequence, and these form the larger scale deformation in the context of the Cape Fold Belt, including the Table Mountain group, which is what we see here. So this is what we saw last week, basically that reconstruction of the four main continents together: South America, Africa, Eastern Antarctica, the Falklands Plateau, and the Antarctic Peninsula. And at this time, there was a subsidence, downwarping as a result of tension between Africa and the Falklands Plateau, forming the Agulhas Sea, which was not a sea that opened up as the Atlantic did to form a mid-ocean ridge. It was, I suppose you could call it a failed Atlantic Ocean or Indian Ocean, and it certainly seems it might have been a precursor of those activities. Later on, there was compression as the direction of the plate motion changed with the movements of upwelling in the mantle below us, started to form compression. And then ultimately the huge deformation of the Cape Fold Mountains that we see today, which when you look at a section through the coast, through the Cape Fold Belt today, running from George, the coastline here, George, through the Outeniqua, across the Little Karoo, up the Swartberg, into the Great Karoo on the north. So where did this Cape Supergroup basin originate? It was a prominent east-west linear belt, originally about 1,200 kilometers long, and extended up to 400 kilometers inland of the coastline as we know it today. And only the shallow marine environment is exposed in the Cape Fold Belt today, comprising the Table Mountain group, the Bockerveld group, and then the Witteberg group further inland. And all of the evidence of the paleo currents depositing these rocks came from the north, northwest, and the northeast, from mountain lands that would have been well inland. And we do know that the Cape supergroup extends in as far as north of Beaufort West. And this is from boreholes that have been drilled in this area. So on that side, that does not occur, whereas on the south to the east of Beaufort West, they do intersect Cape supergroup rocks. So they can determine what the northern limit of the basin was and how extensive it was. But that elevated source area contained granites, gneisses, quartzites, dolomites, and various lavas, and all of those rocks were eroded and deposited in this basin. But the extraordinary thing is that the Table Mountain group is predominantly quartz dominated. There's very little else other than quartz grains, which goes to show that it was a very long-lived and degrading environment where all the finer grained and all the darker, softer minerals were all broken down and taken elsewhere into the basin, so that we have this dramatic sequence of sandstones which remain here as the Table Mountain group. We're particularly involved we're looking here at the Peninsula Formation, which in itself is nearly 3,000 meters thick. The other units here, the Pachrace Formation, which is the glacial unit, the diamictite, and the Cederberg Formation are very narrow and very poorly exposed in this area. Further up in the Elandsberg behind Phillips Kop, it is exposed, and there's quite a nice unit there you can see against the mountain sides. But here around Hermanus, it seems to have been faulted out of place and is not seen. That describes, and of course the handouts on your self-guided walk, you'll be able to read information about what types of rocks make up this Table Mountain group. And this slide will show you the environments, in fact, in which these occurred. The Peninsula Formation, including the Table Mountain, part of the Table Mountain group, was a broad fluvial plain, low energy, with this very sandy stream contents being washed out of the hinterland. Of course, one must remember back then there was no vegetation on the surface of the earth, so erosion was probably quite dramatic, and it was pretty easy to wash the quartz grains out of the debris coming from those mountains, and to concentrate them nice and clean in this Peninsula Formation and the Table Mountain group as a whole. These particular depositional environments, you can get cross-fetted sandstones made by both wind and water. On the left, you see a photograph of the wind-blown aeolinite at the Kelders. And on the right-hand side, a water-laid cross-bedded unit, which contains, interestingly, mudflakes and pebbles in a cross-bedded sandstone. So this is rather unusual in my mind, and other sedimentologists may have another idea about how you can get these two things together. Mudflakes being rather fragile and quartz pebbles rather hardy. So it's an interesting display of what goes on in these rocks. The other depositional environment, which is of great interest, is in fact this glaciogenic unit in the Pachrace Formation, which really reflects the results of a glacial event, one of the dramatic coolings of the Earth, where large glaciers covered areas of the globe, and the fine-grained till material washing out from these glaciers, and pebbles and even larger rocks being dropped from icebergs end up in this unit. In the Pachrace Formation, we see mostly shaly, sandy rocks with scattered quartz pebbles in them, which are part of that till sequence. So this once again brings us to a summary of the geological map, where you've got the outline of Walker Bay. Point here, Walker Bay here, with these major structures, these faults that have broken up the terrain inland here, and the large synclinal structure of the Bokkerveld in Walker Bay and up the Botterivier, up the Botterivier Valley here. And the rest are all the sandstones, quartzose sandstones, and in the middle here in the Walker Bay embayment, you've got a large sequence of the younger Cenozoic, the Darsdorp and Quaternary sediments, which are the present day redeposition of rocks very similar to the Peninsula Formation and the Table Mountain Group. In this area, we see various types of folds and faults, and these diagrams describe the terminology that goes with that. You have the folding, which sometimes is harmonic. We have continuous axial surfaces, or disharmonic, where the axial surfaces are discontinuous. And the Monster Corp is a very spectacular example of the disharmonic folding, which we see virtually every day. Along the cliff path here, the actual outline of the coastline here is demarcated by various faults, fractures, and joints, which appear at all scales. And sometimes these joints are very close together, forming us these narrow clefts like this, or wider clefts, or large embayments, and in different directions. But when you get down to small scales, like a fixed pool here, the same directions all apply. And that's one of the features of fracturing in rocks, is that they occur at all scales in similar directions, all related to the dominant stresses, the folding that has occurred in these rocks. So once we start our walk from Geowings, the next stop would be outside the Windsor Hotel, where we think would be an opportune place to actually put a time scale, and we're debating still how to do this. And you may all have seen the rope trick done by Dave Morant, and we thought we might do something with a rope trick along the wall in front of the Windsor Hotel, which would sort of give us the time frame in which we're working, and hopefully would be a permanent display. But within this incredible long sequence of 4.5 billion years, 4.6 billion years, the Table Mountain or the Cape Supergroup is a relatively small portion at the bottom there in the Paleozoic, covering about 150 million years. And then right at the top, finally, the Hermanus terrace was carved onto those rocks at about 2 to 5 million years ago. So there's a lot of the sequence in between those two events, which are not represented in this part of the world. And in fact, the Cape Fold Belt, the Cape Mountain land, and all the winelands round about are a pretty unique example on the Earth of a mountain landscape that has not been extensively glaciated to the extent that everything is removed. So we have a huge gap between the Cape Supergroup and the younger formations in which we grow our vines and wheat and such like. So this is approximately where we'll be starting this morning, and it's intended that each of these stops is self-explanatory. So we'll look back on that view with the Piering, which is an example of the open folds. Along this part of the cliff path, the folding is very open and very different to what you see in the Monster Kop. And those folds in the Monster Kop seem to plunge southwestward, just offshore of the cliff path in this region here. We've got quite a prominent seaward sloping terrace as a result of that folding, which allows the wave surge and storm times to wash up into that area and keep it clear of vegetation. When you get to Fixed Pool, you could go down and see some really interesting examples down here. Here's the pool here. If you walk along on the rocks there very carefully, you'll see this sort of open fold here. And above it, there's an example here of some rather unusual multi-directional deformation. There have been some write-ups by visiting geologists from elsewhere on what has happened here. You've got quartz veins formed by tension and then folded, and then also being displaced again. So we've got multiple phases of dilation and movement. And then just behind the bar fridge at Fixed Pool, there's this low angle thrust zone, which has on echelon quartz veins describing the movement, the direct movement, direction of movement. So you can observe those in your own time and ultimately have a drink for lunch there at Fixed Pool. Moving on along the coast, we have these magnificent faces. And if you go to stop 5, which is on bench 24A, looking to the west, you see these faces that give you numerous examples of cross-bedding, planar bedding, possible thrust planes, indicating movement from south to north as part of the deformation. And then up the top here, of course, this is the level of the 20, 30 meter Hermanus terrace. You have veins in here, vertical joints, and there is planar bedding and cross bedding. Carry on along there, you have another spectacular exposure at bench 19, looking west again, because these seem to be very prominent on the east-facing cliffs, with these numerous thin-bedded, cross-bedded sandstones, sigmoidal ladder veins, result from vertical movement along this prominent fracture zone that seems to run along the coastline, and is maybe part of the reason why that coastline is there. At stop 7, you have a very nice close-up view of the 3 5-meter terrace and the resulting wave action on those terraces. You can see cross-bedding in this unit here, prominent thicker beds in here with poorly etched out cross-bedding. You have very prominent fracture here, which might be similar to that which we saw with the ladder veins previously, which forms an exposed joint that is isolated the pre-external from the mainland. And interesting here, this sloping surface here gives a good example of the effect of the waves on these surfaces, which etch out the prominent fractures and the jointing in these surfaces. And you can see it diminishes as you go up the swash zone. And I think this sort of feature is a very interesting feature which you can use to identify surfaces which have been affected by wave erosion along this coast, and we'll point out a few of them further on. To the left of this site, there is a cave which is being caused by wave erosion. It's not known whether it's ever been inhabited. I've certainly never tried to climb in there, but what you can see if you go further around to the right here is that it's filled with rubble and boulders, and may not have been particularly accessible for habitation. But it is perhaps similar to the cave at Hoy's Kopje, which was most likely eroded when the Hermanus terrace was formed, and in fact occupied in later years by humans or early humans, similar to the Kelders. We carry on down to Tamati Bank, which has always been a question, is why is it called Tamati? Well, right out on the end of Tamati Bank at stop 8, bench 16 and 17, the quartzose sandstones contain a lot of iron, and they have this very pink-red color, much like the color of a half-ripe tomato as it's described, and that is oxide staining. And not to be confused with the lichen growing on these rocks as well, which are more orange and gray. And particular thing about this oxide staining, it seems to be very prominent at a level which relates to the old land surface on which Hermanus stands. And there's lots of evidence around Hermanus of this really orange and red iron staining in the soils and in the rocks, which I think relate to that long period of exposure during the Pliocene and Pleistocene when that terrace was cut. Now, in going back to, well, in showing some people recently around and up to Tamati Bank, we stumbled across this. So I stumbled across this thing here and wondered what on earth was this. And then just recently at Kleinmont, Jean Milan had shown us some slabs of trace fossils, these worm-like structures in the sandstones there. And I went back, took some more photographs, and I've conferred with him, and this looks like this might well be a trace fossil. Trace fossils are evidence left by organisms that don't have hard parts, that can be properly fossilized, but you do see their remnants in what would have been soft sediment at that stage. And in this case, it seems to show burrows as well, or evidence of burrows where the worms were in the sand there, where they crawled across the surface, sort of arcuate features like that. The ones at Claymont are far more impressive. And in fact, John has got one which actually has the mirror image of that. It used to sit on top of this, so it's even more spectacular. We don't have a name for this. There are other trace fossils known from the Valencia Formation and the Table Mountain group, which are the trace fossils from trilobites, but they're not shaped like this. They're a bilobed, feathered type of trace fossil. Then we've got a little test for people who want to decide for themselves what they see in these rocks. So that's quite a nice exposure as you go to stop 9 and bench 15, 16. You can see these, you can see crossfading joints, thrust planes, and sigmoidal quartz veins. So you can test yourself on your knowledge when you get to this point. Then as you go down, further down, you drop down along the stream of Arundel Street, and there's a very prominent, like I believe to be a shell midden, or archaeological rubbish heap along at this level, which is right at the bottom of the cliff there, down on the 3-5 meter bench. And it's not been excavated, so we don't know anything about the age or what else the inhabitants were doing there. Clearly they enjoyed their shellfish, and there was lots of evidence there. A lot of that has been reworked into more recent beach deposits a little bit further down. From here to stop 11, you walk along with a 3-5 meter terrace notch point up to stop 11, which gives you these spectacular 3-dimensional views of cross-bearded sandstones. These rocks are laid down, we believe, in relatively shallow water, maybe quite similar to that in Walker Bay, between 25 and 90 meters in depth. But they clearly have had all the finer grained clays washed out of them. They're composed entirely of sand, of quartz grains. Current directions appear to be towards the south and southeast. These current directions have been disturbed affected by the folding of the Cape orogeny, and in these outcrops, even the small scale folds are evident. You can see quartz veins formed from fluid circulating during regional metamorphism as a result of deep burial and folding. So that's quite a spectacular outcrop. And it's also quite, although it's at quite a high level, it's kept quite clear of vegetation. In fact, when you go there in a storm, you'll understand why. There's a lot of sea spray that blows up on there, and that inhibits the vegetation. A little bit further along, it's stop 12, bench 11. Prominent outcrop of these swarm of quartz veins in the cross-bearded sandstone. And these seem to be tension gash veins related to folding during the orogeny. And such vertical veins generally occur in the hinge zones where tension is greatest, as well as being associated with tangential faulting and thrusting, where on the right-hand side, or in both, you can see the relative movement indicated by the arrows, which would have caused that opening. Down below this site, there's the Rietfontein bench, where we've got, so at about 5 meters below this site here, where you have this evidence of deformation in brittle rocks, brittle deformation. Down below, this is another new discovery on this Rietfontein bench. You've got this extraordinary evidence of soft sediment deformation. So this is deformation that occurred before the rocks were consolidated, and probably as a result of something in the basin. Maybe there was an earthquake that set this waterlogged sediment moving, and it formed these irregular disharmonic folds in the sediment. And immediately above this, there's quite a well-developed gravel lag deposit, which I'll show you an example of a little bit later. And then right up above on the terrace, there's this brittle deformation. So the juxtaposition of the two here is quite an interesting exposure. So that's the Rietfontein bench. On the left, there's a lot of shell material, which I believe is also a possible midden. And it's interesting that these shell deposits seem to be concentrated around the two areas where there are freshwater streams still flowing today. The previous one has the stream that runs down from Arundel Street, and this one is the Rietfontein stream, which is quite pronounced. The wooden bridge goes over the stream just prior to this. You can see here the 3-5 meter terrace. You've got the 20-30 meter terrace on which Hermanus is situated. You have evidence of here of how the waves loosen these massive blocks even, and then progressively will move them back when they have a large enough storm, or when sea level rises, move it back towards the cliff, which is slightly offshore, and drop it into the sea. Here you see a large number of blocks that have been broken up. And then down here below, you see very closely spaced jointing, which forms a very narrow cleft, which is evident below. Then as you come to stop 15, towards the end, towards New Harbour, there's a feature there, it's labeled Blowhole on the car park. It's not particularly active, and apparently waves used to crash into this cavity below the rocks, and the air was compressed and escaped noisily through this fissure. And you want to ask yourself why it's now quiet. And it's quite possibly with the building of the New Harbour Wall, reflected the impetus of the swells coming in. And as a result, the blowhole is now quiet. Although when you do go there, and as the swell rises and falls, you can see the water pumping up through that fissure. Right behind that bench too, there's a really good exposure of a pebbly layer, similar to that I mentioned previously, which represents, I believe, a bit of a hiatus in the cross-bedding sedimentation in the sequence, where all the finer material was washed out further into the basin, and these coarser, heavier fragments were left of what we call a lag gravel deposit. And they all seem to be particularly one size and sub-rounded. They've been around in this process of rounding and erosion for a long time, even some unusual elongated fragments. And this particular spot seems to form 2 or 3 thin layers. So that tells you something about the history of the deposition here. So that's been a fairly short discourse. We come to the end of this, and you can return along the cliff path and review your experience, or you can walk back along the road and have a look at the architecture, and then make plans to take on one of the other tours which we hope to have available for you. Thank you very much.
Thank you very much, John. Please, if there are any questions, go ahead. John, I wish to start with an absolute layman's question. What are crossbeds and sigmoidal structures?
Okay, well, I think that certainly on the walk today, we'll see what crossbedding means. Basically, you have planar beds and crossbeds. Planar beds are nominally horizontal, and crossbeds are a result of large-scale ripples where the sediment is washed up over a peak and then slides down on the other side into layers which form beds at an angle to the planar horizon. This very nice more recent exposures around the kelders, where you can walk right around these boulders and see them from more recent events, but certainly on the cliff path. Top 11 there is very beautiful 3-dimensional aspects, which shows the direction in which the sediments were moving in the basin with the currents that were working through the water column at that point. Sigmoidal is a geometric term which describes a broad S shape of the veins as they've been deformed by the movement in the rock along a particular plane.
Here is a question in the chat box. What is the global extent of the late Audiovision glaciation as represented by the Pachrace Formation?
Okay, for that one, I'm going to defer to Cameron.
We've been able to map the Pachrace Formation reliably from the Matsakama Mountains, it's there around Van Reinsdorp. It's about the most northern extent. It comes down as far down south as Table Mountain. There's some exposures over there. And as soon as you pass over about 31, 32 degrees east longitude, it seems to disappear. So it's only just in this western part. So where you guys are in Hermanus, you guys again are probably on the extreme margin of the Pachrace Formation. But on a global scale, this glaciation event extended into South America. So in northern Argentina, there are exposures of the equivalent in the Serra de la Ventana, as well as in the Tandalila. And I think as well in Brazil, I think in the Parana Basin, as well, there are equivalents of the Pachrace over there. So on a global scale, it was quite broad, but what's quite anomalous about it is that it was a low latitude glacial event. So at this time period, South Africa and its sort of Mikey's in Western Gondwana, where the glaciation was experienced, was at about, I think, inboard of about 15 to 20 degrees south. So it was quite a low latitude, something that would be in the tropics to subtropics. So it's one of the last, or this and the Dwight glaciation event, one of the last big major glacial snowball earth type events. That's in a nutshell.
Is there no evidence of it in the Northern Hemisphere? For instance, in the upper Audiovision in UK?
Yes, so in the UK as well, one does see it over there. So in the UK, was the Hermanus glaciation event. So one does see it in the Northern Hemisphere. It's more prevalent in the Northern Hemisphere than what it is here in the present-day Southern Hemisphere. So during the late Audiovision, those regions, UK and I think Eastern North America, were at high latitudes. So to experience a glacial event at high latitudes wouldn't be out of the realm of impossibility. The recent timing that we can see from these glaciation events is that the Pachrace Formation is slightly younger than the glaciation event that was experienced in the Northern Hemisphere. It's by a couple million years. The reasons for that, I have no clue why there is this discrepancy. But even with the fauna that you see over there, the so-called Hermanus fauna, what we do see is that in the Northern Hemisphere, when these little okies go extinct, they seem to have migrated down to South Africa and found refuge over here. So they were cold water loving organisms. So the big question is, why would a glaciation event swing from high latitudes to low latitudes? There must have been something that went awry with the way that Earth functioned. And I guess this is at the same time period that these very early protoplants were making their appearance. You have a massive contribution, biomass contribution on Earth. So maybe Earth's biogeochemistry was just out of swing while one saw these things.
Thank you, Cameron. That answers my question very comprehensively. Thank you very much.
I think an important thing about this, as the last question elucidated, I would say that this type of geowalk has been put together by a geologist trying to be a lay geologist. It's intended to really try and open up questions amongst the lay population and interested parties. I have no pretenses to know everything about the Cape Supergroup, but just to try and highlight some of the interesting features. People can get an introduction and then carry on and follow their noses from there. And I hope that our links to the Geological Society website, people can go from there to then follow up other reference sources and to follow up other information, help them understand what they're looking at.
The other thing I wanted to mention, John, I know you touched on it in your presentation, was these geotrails that you've set up over there. I'm not sure if you are aware, but with the GeoHeritage Western Cape Committee, we have an interest in geotrails to try to help promote geoheritage in our province in particular, since they're just about everywhere you go. It's fascinating, the scenery and what have you. One of the other things that we are working on is we are setting up a GeoHeritage app that you can install on your phone. And what this has is an interactive geological map, atop which there is a layer that one can put geosite information, geotrails, and what have you. The intended idea is that people like you and others that want to actually promote a geosite or a geotrail can do this from your cell phone, where you'll be able to put these stops down. And I like this idea at the benches. It's quite nice, because then you can walk and sit down and have a smoke and or a drink or whatever and enjoy the scenery whilst you take your phone out and you'll be able to have a look at this stuff. In this app, we will of course be introducing a system of which a very easy foolproof way in which to capture these data and to promote these sites. And then also, if any of these trails require very accurate GPS done, we can come out there with a DGPS and make these trails quite accurate. Thanks.
I might just mention that we had a talk about the subject and the development of the app a few weeks ago. The talk has been uploaded to the U3A and the Geologist YouTube channels. And the title of the talk is The New GSSA WCB. In other words, Geological Society of South Africa's Western Cape Branch website. Explore the Cape's Geology by Wendy Taylor. And this is the link to access this talk.
Is there any local evidence of the age of the two terraces, the 3 to 5 meter and the 20-meter terraces? Do we have any information from locally on that?
John, there doesn't seem to be any specific information. Haley Cawthra at the Council for Geoscience is the one who's most in the loop on that. But I think an interesting thing about these surfaces is one can probably get some idea of the absolute or even relative ages, other than in relation to other features, other terraces. But the erosion on them tells you something about how long they were exposed. And the wave erosion is really quite specific, I believe, to these surfaces. The figure that I have in there, I think of 20,000 years, is one that I believe is commonly related to a recent interglacial period and could have been responsible for that particular terrace. But the folding and the slopes of these terraces, the rocks here, make it quite difficult to be absolute. And Haley has given us some direction as to how we're supposed to measure these things, but you need very accurate elevations of the actual notch point. In other words, the furthest point inland where the terrace is exhibited to then start to correlate them with similar features elsewhere. That's about as much as I can tell you, John.
Is it plausible that the higher terrace might represent the highest point of the last interglacial?
I think that they do have some data information on the higher terrace, the 2030. In my mind, a feature that precludes that is, in fact, that this surface, the Hermanus terrace, is commonly populated by a lot of this reddish sand, this really ferruginized sand and gravel, which also commonly occurs on the older terraces around Clarence Drive and has been referred to as tertiary in age. Tertiary covers everything from 65 to nearly 2 million years. But there's a long period of weathering in southern Africa during that time, which really was part of the African land surface. And I think there's a lot of evidence for that, where you have this heavily iron cemented and in fact ferricrete horizon development inland, which in my mind seem to be all connected. So I think that sort of evidence indicates to me that the Hermanus terrace is really quite old in the relative sequence of events.
So, John, does the bench upon which Hermanus is built, with the mountains in the background, represent two different periods? The mountains being the Cape Fold Mountains and the bench something else. Is that correct?
Exactly. There's about 400 million years between them. You know, the bench, the terrace, the bench that we live on here was formed, you know, when the continent was currently in its current shape, and sea levels were rising and falling in relatively recent times, certainly the last 5-6 million years. But whereas the Cape Fold Belt, the structures and shapes and the faulting within that really go way back into about 250 million years ago.
Cameron, on the Pachrace, is there an indicator which would sort of separate it from those pebbles that have been left behind, or very, very small class, the class size, to the stuff that John found, where he found some pebbles that have been left behind as a result of a winnowing process? How would you know which one you're looking at Pachrace?
Can I answer that? My simplistic assessment is you look at the surrounding contents of the rock unit, and what I call lag gravels, they're totally populated by quartz fragments, quartz pebbles. They're all, even the intergranule or the interpebble is all quartz. Whereas in the Pachrace, you're looking at a more shaly, more clay-rich, even finer grained material than you have in the lag gravel deposit. And whereas in Pachrace, what I've seen, the quartz fragments, whether they're pebbled or even bigger cobbles, are very isolated. In these lag gravel deposits, the coarse-grained quartz fragments are quite concentrated on one horizon.
Yeah, that's correct, John. That's one of the ways that you can see it, as John has said, is that so what you do see with the clasts, you will see a wide, in glacial type setting like the Pachrace, you will see a wide sort of range of types of clasts. So you'll see differences in shapes. So not all of them will be rounded, some of them will be angular. You won't see these things concentrating together. You wouldn't see any sort of real sorting. It would be almost at random. The other ways to see it is with the material that's between the clasts or that the clasts are surrounded by. If you look at that material as well, it will also be quite mixed. You will get some gravel with some mud, and also the stuff will be quite angular and not well sorted. Whereas what John was showing at stop 12 with those peninsular gravels over there with the conglomerates, you'll see is that the sand is a lot finer, it's a lot cleaner, it's got a better amount of sorting, or what we call sorting in it. The other way as well with some of these Pachrace pebbles is that you'll see is that they'll tend to have one side that's quite flattened and marked on it, and that's essentially as this ice sheet was moving along the landscape and plucking up rocks from the substrate it was moving over, it would scrape and grind these things on the substrate, flattening the one surface. If you guys find any of those sorts of pebbles, that's a nice, clear indicator of a glacial type of transport.
That's great. Thanks very much, Cameron. Yeah, I didn't think of the striations, and in some cases they might be quite small.
John, thank you very much. Thank you for the preparation, and thank you for the presentation. And particularly thank you for what you geologists are doing, and really looking forward to these information sites and the whole geotrail trails that you're working on. So thank you everybody for joining us this morning. Goodbye.